Okay, so I've had some requests for the page 440 assignment, which actually is past due at this point. But I figured since some of you are asking for some help, even though it's a little bit late, and technically this should have already been turned in, and a lot of you guys did already turn it in. If you've looked at the web page for this week, you've noticed that you have a test over this week. So even if you've already done this assignment and turned it in, if you had some questions about it, or maybe there were a few problems you didn't know how to do or you didn't know the answer to, you really still need to watch this video, because your test this week is on chapters 8 and 9, which is the probability sections that we did, and then the data analysis and the statistics sections, like the normal distributions from page 440. So whether or not you turn this assignment in already or not, still an excellent help video if there are still some things that you're a little confused about. If you look at number 5, the first thing you need to notice about number 5 is that it goes with number 4. So you have to go back to the information above number 4, which might be part of the reason why there was some confusion here. If you go back to the information at the very beginning of the problem for number 4, it says a data set with a mean of 75. So notice that I've created a number line here, and I've put my mean of 75 right in the center. And then it says it has a standard deviation of 3.8. So I added 3.8 to get the 78.8, and I added another 3.8 to get the 82.6. And then I subtracted 3.8 to get 71.2, and I subtracted 3.8 again to get the 67.4. If you're wondering why I've done that, or why I created this number line, the reason why is because it tells me that this data is normally distributed. So if I know that it's normally distributed, then I know that I can create a number line with the mean in the center, and I know that every time I add or subtract the standard deviation, I'm going a standard deviation away from the mean. So this is one standard deviation above the mean, 2 standard deviations above the mean. This is one standard deviation below the mean, 2 standard deviations below the mean. Okay, I also drew a little bell curve or a normal curve above it. Why? Because it tells me that it's normally distributed, which means that there's a certain percentage of my data within each of these sections. Okay, now let's read the question. Number 5 says, what percent of the data is from 67.4 to 82.6? Well, find those numbers on your number line. If they're not on your number line, then you may need to go some more standard deviations out. But if you look, you will see that both of those numbers are on my number line. 67.4 is down here and 82.6 is up here. So if I want to know what percentage of my data lies from here to here, then I need to go to those percentages that are in your notes and that we talked about in the lesson video. Remember that there are certain percentages of your data is within each of these sections. So 34% of your data is here. Another 34% of your data is in this section. So as you go one standard deviation away from your mean, you have 34% of your data on each side. Between 1 standard deviation and 2 standard deviations is another 13.5% on both sides. Okay? That's really as far as I need to go as far as filling in my picture and all my information, because I just want to know my percentages from 67.4 to 82.6. That's going to be these 4 percentages right there. So what I need to do is I need to add those percentages up. That will tell you what percentage of your data is going to be within these 2 standard deviations from your mean, below and above. Okay? So you're going to add 13.5 plus 34 plus 34 plus 13.5. And if you add those numbers up, you will get 95%, which is your answer for number 5. Okay? Some of the other problems that were requested were 16 and 17. 16 and 17, guys, is the same way. They go with number 15 above it. So if you weren't sure how to do those, it might be because you didn't realize that you needed to use the information that goes with number 15 to do those problems, okay? So let's look at 16 and 17. I'm going to leave some parts of this because I can use some parts of this probably again in this problem. Notice I'm erasing the numbers in the number line because those numbers change. But I'm going to leave the basic picture with the percentages because the percentages don't change. It's the numbers on the number line that do, but not the percentages in your bell curve. Okay? So again, we need to go all the way up above number 15 to create our number line. It says the price of a certain brand of printers is normally distributed with a mean cost of $215. So that's going to be my new middle number, is going to be $215. And it has a standard deviation of $35. So we're going to add 35 to get to that to get the number that's going to be one standard deviation above that. So 215 plus 35 is 250. Then add another 35. And you get to 85. Okay, now let's find our numbers below our mean. So go back to your 215 and subtract 35. That's going to give me the 180, and then subtract 35 again, and you get 145. Okay, so we've created our picture now to go with 16 and 17. Now let's read 16. It says, what proportion of the printers cost less than 145? So look on your number line and see if you can find 145 on your number line. 145 is way down here on my number line, 2 standard deviations below the mean. Okay? I want to know what proportion, or what that really means is what percentage. What percentage of my data is going to be, or in this case, what percentage of the cost of the printers is going to be less than $145. So what I'm looking for is the percentage of my data in this part of my graph. I can see that it's going to be a small number. There's going to be a small percentage of my data is going to lie within that part of the graph. Here's how I would do that. We did one like this in the lesson video. I said, okay, think of it this way. Remember that the mean cuts your data in half. 50% of your data is over here, 50% of your data is over here. So we know that all of this whole, from the mean to the left, is going to be 50%. But I don't want to include this 34 and 13.5. So what I'm going to do is I'm going to subtract that part out that I don't want. Okay? So all of this is 50. Subtract out these 2 sections that we don't want to count or include. And that'll give you what's left over, which is going to give you everything from here to the left. Okay? So let's take 50, subtract 34, subtract 13.5, and you get 2.5%. That's going to be this little part of the graph over here. Okay, small number, it should make sense that it's a small number. Okay, these problems should make sense. If they're not making sense, you probably did something wrong. Now let's look at 17. Same picture, okay, same information, same picture, everything's the same. What proportion of printers cost more than $250? So now I'm looking for the percentage of my data that's going to be more than 250. So find 250 on your number line, which is right here. I'm looking for what percentage of my data is going to be 250 or more or bigger. So what I'm looking for is this part of my graph. I want to know what percentage of my data is going to be in this section of my graph. Well, I already know that between here and here is going to be 13.5%. I know that section, okay? And actually, you know this section too. Why? Well, because it's going to be the same as this section over here. This is 34%. This is your 13.5%. This is the same as this, okay? Everything from 13.5 out is going to be the same as everything from this 13.5 out. So I can use the answer that I got for number 16, which was 2.5%, to do number 17. Okay? So from 250 out is going to include this 13.5% of my data, but I also want to include the piece outside of that, which I already know because it matches the other side. I already know that's going to be 2.5%. So add 13.5 plus 2.5, and you're going to get that 16% for number 17. Okay. Okay, one more. Another one that was requested was 29. So let's take a look at 29. It says, Miss Burleson surveyed the students in her class to find the number of minutes they spent doing homework each night. She found that the data was normally distributed with a mu, that you may not have been familiar with those symbols, but that's a mu symbol, which means mean of 30 minutes. And sigma, that's a Greek letter called sigma, equals 10 minutes, and that's your symbol for a standard deviation. So the 30 minutes is your mean, and your 10 minutes is your standard deviation. So again, I'm going to leave part of this picture, and I'm just going to erase the numbers on my number line because that's really the only thing I need to erase. Okay, and now I'm going to put 30 for my mean. 30 minutes is my mean. 10 minutes is my standard deviation. So if I add 10, I get 40. If I add another 10, I get 50. If I subtract 10, I get 20. And if I subtract another 10, I get 10. So there's your new number line. Okay, part A, what range of time spent doing homework contains the 68% closest to the mean? Your 68% closest to your mean is going to be one standard deviation above and below your mean, because here one standard deviation below is 34%, one standard deviation above is another 34%. If you add those together, that's 68% of your data. So the range of time spent doing homework that's in that 68% of your data is going to be your range of numbers from one standard deviation below to one standard deviation above. That's going to be your 20 and your 40. So students within 68% of your students are going to be in a range between 20 and 40 minutes of studying each night. Okay, that's going to be that will include 68% of your students, or 68% of your data are going to study between 20 and 40 minutes each night. That's part A. Part B says, how much time spent on homework would you expect from the 2.5% of the students with the least time spent on homework? Well, if you remember the problem that we just did, we know now that everything from 2 standard deviations below that and everything 2 standard deviations above that is 2.5% of your data. Okay, so how much time spent on homework would you expect from the 2.5% over here of the students with the least time spent on homework? Here's your 2.5% with the least time spent on homework right here. They spend less than 10 minutes studying. Okay? 2.5% of your students are going to be expected to spend less than 10 minutes studying. So your answer to part B is going to be less than 10 minutes. You would expect them to spend less than 10 minutes because this is your bottom part of your data, of your students. Part C, Jeffrey studied 25 minutes last night. What percent of the students studied fewer minutes than Jeffrey? Round to the nearest hundred. Okay, so we need to figure out where Jeffrey is in this mix if he studied 25 minutes. If he studied 25 minutes, he's right here on the number line. He's in the first standard deviation below the mean. What percent of the students studied fewer minutes than Jeffrey? So we need to figure out what percentage of the students is going to be from here this way. This is the percentage of students that have studied fewer minutes than Jeffrey. And Jeffrey's right here at 25, right in the middle of 20 and 30. Okay? So we know that this section is 13.5. We know that this section is 2.5. And then we know that 25 is going to be right in the middle. So you could make a pretty good estimate of this problem. Okay, so if you didn't get the exact number for this, of what I had on the answer, that's okay. Just make a good estimate. You can make a good estimate for this because we know that we're going to include this 2.5%. We know that we're going to include this 13.5%. And then make a good guess on, if you're right in between 20 and 30, you're going to have a little bit bigger number here than here. See how this part of the graph is more than this? So you can take that 34, you can't exactly split it in half. Even though 25 is exactly in between the 20 and the 30, you can't just cut the 34 in half. But you could estimate it that way. So let's just figure out what would we get if we were to cut that 34 in half. Well, 34 divided by 2 is 17. So I don't know, I think maybe a 15 might be a good estimate for that. That maybe this side might be 17% hold on, no. 17 would be if we were to cut it in half. So what you might want to do is maybe make that part 20 and maybe make this part 14. I'm just estimating, guys. That's all I'm doing. I know that this section is 34%. I know I need to cut it in half. I know that there's going to be a little bit more on this side than this side. So I'm just going to estimate it to be 20 and 14 here. Still adds up to the 34% that I know I need for that whole section. So just an estimate is going to be 2.5 plus 13.5, and then I'm just going to estimate that at 14. And then just add the numbers up. Okay, and I don't know that that's going to be exactly what the answer that the book had, but I know that it'll be something close. So let's add those numbers up. And I'm getting 30. I don't even know what the book had. I can look. Okay, the book had 30.85%. Very close. Okay, and I just guesstimated it. But you can make a pretty close estimation for these problems usually. Okay, so this was several problems out of your homework. I hope that those of you who might still have had a little confusion with this, watch this, pay attention to it, because you do have a test this week and you are going to have questions just like these on your test this week. So very important that you know how to do this, even if you already turned in the assignment, okay? All right, I will talk to you guys later.